Welcome to the deep dive. Today, we're looking into text-to-image generation. It's pretty incredible stuff. You've seen the images AI can create from text prompts.
Absolutely stunning sometimes.
Right. But the cutting edge isn't just making images anymore. It's about consistently getting high-quality, semantically accurate ones.
And just as importantly, figuring out how to properly measure that quality. It's a real challenge.
So that's our focus today. We're diving into two, well, pretty significant innovations based on some recent research.
That's right. We'll be exploring a new reinforcement learning method first. It's aimed at making T2I training much more stable, addressing some unexpected issues that crop up.
Okay, stability first, and then?
Then we'll shift gears to evaluation. There's a new unified benchmark designed for really fine-grained assessment. It helps us understand what these models can really do beyond just, looking impressive on the surface.
Got it. So our mission for this deep dive is to unpack how these advancements deal with core problems. Things like image quality actually decreasing during training sometimes.
Which sounds counterintuitive, but it happens.
Yeah, and also the limits of how we currently evaluate these models. The goal is to give you a clearer view of the path forward for T2I.
So let's get into it.
All right, so creating these powerful T2I models often involves reinforcement learning, RL, specifically something called Group Relative Policy Optimization, or GRPO. Think of it like training an athlete. They need feedback from a coach, right?
Makes sense.
In this case, reward models act like those coaches. They score the images the T2I model generates.
Giving it a kind of report card.
Basically, yeah, telling the model, good job here or needs work there. This guides the learning. So higher scores should mean better images, you'd think.
You would think.
Yeah.
But that's where things get interesting. What the research shows is a real problem with many existing pointwise reward models.
Pointwise meaning they score each image individually.
Right. And the issue is they tend to give incredibly similar scores to images that are, well, pretty comparable within a group.
Like how similar are we talking?
We're talking tiny differences. The papers show examples like scores of 0.3457, 0.3530, 0.3496. The standard deviation is minuscule.
Okay, so the coach is basically saying all these attempts are almost exactly the same quality.
Pretty much. The reward model doesn't see much difference.
Then this leads to something called illusory advantage.
That's the term. So you have these tiny, tiny reward differences like that 0.0073 gap we just mentioned.
Almost nothing.
But then the system needs to calculate advantages for the policy optimization step, trying to figure out how much to change based on that feedback.
And it blows it out of proportion.
Hugely. That tiny 0.00073 difference can get amplified into a massive advantage difference, maybe like 2.83 in the example shown.
Wow. So the AI is basically overreacting to negligible feedback.
Kind of like hearing a whisper as a shout. And the consequence is reward hacking.
Reward hacking sounds bad.
It is. The model starts over-optimizing for these tiny, amplified, almost meaningless reward signals.
So its internal score might go up?
Exactly. The score looks like it's improving. But when you actually look at the images being generated over time, the quality often starts to degrade.
Degrade how?
Visually, you might see things like colors becoming way too saturated, just blown out, or images getting progressively darker. It depends on the specific reward model being hacked.
So the model learns to chase these tiny score bumps, even if it makes the pictures worse, like gaming the system.
That's a perfect analogy. It becomes a clever student finding loopholes in the grading, not actually learning the material, or in this case, how to generate better images.
Okay, so that's a major roadblock in training. The method meant to improve the model actually makes it worse in some ways. We needed a different approach.
And that brings us to Pref-GRPO. It's presented as a solution specifically designed to tackle this illusory advantage and reward hacking problem.
Pref-GRPO. And how does it work differently?
The core shift is moving away from maximizing that absolute reward score. Instead, it focuses on pairwise preference fitting.
Pairwise preference, so comparing images against each other.
That's the idea. Instead of giving each image a standalone score, it uses a pairwise preference reward model, or PPRM.
Another model.
Yes, but this one's job is simpler. It just looks at two images from the generated group and decides, basically, I prefer this one over that one. No precise score needed.
Just a relative judgment, like A is better than B.
Right, and from all these pairwise comparisons within a group, you calculate the win rate for each image.
Win rate, meaning how often it was preferred.
The proportion of comparisons where it came out on top, that win rate then becomes the reward signal used to guide the main T2I model's learning.
Okay, I can see how that might be different. What are the advantages of doing it that way?
Well, there are three key benefits highlighted. First, you get amplified reward variance.
Meaning the differences become clearer.
Yes. Because you're using win rates, good images naturally push towards a rate near 1 and weaker ones towards 0. The gaps between good and bad become much more distinct, giving a clearer learning signal.
Makes sense. What else?
Second, enhanced robustness. Because it's focused on relative ranking, not chasing tiny absolute score increases, the model is less likely to over-optimize for those marginal gains. It's less sensitive to noise or small biases in the reward model itself.
So it's less likely to hack the system.
Correct. And third, preference alignment. This pairwise comparison method is actually much closer to how humans evaluate things, especially similar images. We often say, I like this one slightly better.
True, we don't usually assign decimal scores in our heads.
The reward signal ends up capturing more nuanced quality distinctions and aligns better with what we'd consider a genuinely better image.
And did this actually work in practice? What did the results show?
The results seem quite strong. The research reports that Pref-GRPO leads to more stable and directional advantages during training. It effectively reduces that reward hacking issue.
Quantitatively. Any numbers?
Yeah. They benchmarked it and found substantial improvements in both semantic consistency, how well the image matches the text, and overall image quality.
For instance?
On one specific benchmark, UniGenBench, which we'll talk more about, Pref-GRPO showed nearly a 6% increase in the overall score compared to a standard unified reward approach.
Okay, 6% is noticeable. Any specific areas?
What's really interesting are the jumps in specific capabilities, like a 12.7% improvement on generating text within images, and about 12% on tasks requiring logical reasoning. These are often tricky areas.
Wow, those are significant gains, especially in logic. And visually.
Qualitatively, the examples provided show Pref-GRPO generating images that are much more faithful to the complex prompts, avoiding the oversaturation or darkness seen with the pointwise methods that suffered from hacking.
That sounds very promising for training stability. It seems like a much smarter way to provide feedback.
It definitely appears to address the core issue of reward hacking by changing the nature of the reward signal itself.
Are there downsides? Is it harder to implement?
Well, it does require training that extra pairwise preference reward model, the PPRM, and that model itself needs good quality preference data to learn from.
So there's an upfront cost gathering that preference data.
There is. But the argument is that the payoff in terms of training stability and final image quality, especially alignment with human judgment, makes it worthwhile. It seems like a solid path forward.
Okay, so Pref-GRPO helps us train better models. But that brings us to the other side of the coin, evaluation. How do we actually know how good these models are, especially in detailed ways?
That's a critical question. We've got these incredibly powerful models now capable of amazing things. But just saying a model is good isn't enough.
Right, we need specifics. The research points out that many existing benchmarks are a bit, coarse. They might give an overall score, but don't dig into the details.
They often cover only a narrow range of abilities or subdimensions and don't really let you assess performance on each specific skill, like handling specific types of relationships or attributes in the prompt.
So we need a finer-grained look.
Which is exactly the motivation behind UniGenBench. It's presented as a unified benchmark specifically for fine-grained semantic consistency evaluation.
Unified and fine-grained. What does that entail?
The goal is to move past just general quality scores and really drill down into how well the T2I model follows detailed instructions. Understand its capabilities and limitations in a much more nuanced way.
And how is it structured? Is it just thousands of prompts?
Actually, no. One interesting aspect is its efficiency. It uses a set of 600 prompts.
Only 600. That sounds quite small for a comprehensive benchmark.
It does, but they're very carefully designed. These prompts aren't random. These span 5 main creative themes, things like art, illustration, film, and storytelling.
Okay, broad coverage.
And within those themes, they cover 20 different subthemes. More importantly, the evaluation itself is broken down into 10 primary criteria and then further into 27 specific sub-criteria, or test points.
Ah, so the depth comes from the detailed evaluation criteria applied to those focus prompts.
Precisely. It allows for really detailed dissection of a model's performance across a wide range of semantic capabilities.
How do they actually do the evaluation? Is it manual?
They use an automated pipeline built on a multimodal large language model, an MLLM, Something like Gemini 2.5 Tro is mentioned.
Using an AI to evaluate another AI.
Essentially, yes. The MLLM is used both to help construct the benchmark prompts, generating them with specific, structured descriptions for each test point, and to perform the evaluation of the images generated by the T2I models being tested.
That seems efficient, but is it reliable?
The claim is that by providing the MLLM with very detailed descriptions of what to look for each test point, it can perform consistent and effective evaluation. It automates a potentially very laborious process.
What kind of fine-grained things does UniGenBench actually test for? Things that maybe older benchmarks missed?
This is where it gets really interesting. It introduces checks for things that require deeper understanding. For example, logical reasoning.
We saw Pref-GRPO improved on that. What does it mean in an image context?
It means evaluating if the model can handle simple causal or contrastive relationships described in the prompt, like a large red ball on top of a small blue box. That's relatively simple. But what about the older dragon standing behind the younger one? Or ensuring both objects share an attribute, like both red balloons floating? That requires understanding relationships, grammar, quantifiers.
Ah, I see. Those subtle connections that are easy for humans but maybe hard for AI.
Very hard, it turns out.
Ah.
Other examples include pronoun reference. Can the model correctly figure out what its or him refers to in a prompt and depict it?
Like, the cat chased its tail? Does the generated cat actually chase its own tail?
Right. Or hand actions,
Yeah.
accurately rendering specific hand gestures. Or composition relations, understanding made of or composed of, like a statue made of ice.
These are incredibly specific. It feels like we're really pushing the models to understand language much more deeply, not just associate keywords with pixels.
That's the core idea, to move beyond surface-level correlation to genuine semantic understanding and execution.
So what did they find when they used UniGenBench to test current models, both open source and closed source?
The findings are quite revealing. Generally, models tend to do relatively well on prompts related to, say, artistic style or general world knowledge, things they've likely seen a lot of training data for.
Okay, they're good at aesthetics and common facts.
But they consistently struggle with prompts that require that deeper logical reasoning we talked about. Causal links, contrastive elements, complex spatial relationships. That's where performance drops off significantly.
Even for the big closed source models.
While the leading closed-source models, like GPT-4o and Imagen 4.0 Ultra mentioned in the research, tend to perform best across most dimensions, especially logical reasoning, they still show weaknesses. No model is perfect.
And the open source models?
Open-source models like QuinImage and hindring are showing progress. They have notable strengths in certain areas like depicting actions, layouts, and attributes. However, they generally lag behind the top closed-source ones, particularly in areas like grammar and handling compound prompts with multiple constraints.
So UniGenBench really gives us a detailed map of strengths and weaknesses across the board.
It does. Its value lies in that comprehensive dimension evaluation, the rich prompt theme coverage, the efficiency of using just 600 well-designed prompts, and the reliable MLLM-based evaluation pipeline. It sets a higher standard for understanding T2I capabilities.
So wrapping this up, we've covered quite a bit today. We started with the challenge of training T2I models stably.
Right, looking at how reward hacking can undermine progress, even when scores seem to go up.
And we saw how Pref-GRPO offers a potential solution by shifting from absolute scores to pairwise preferences, which seems much more robust and aligned with human judgment.
Effectively mitigating that hacking problem and leading to better semantic consistency and quality, especially in tricky areas like logic.
Then we shifted to evaluation, the challenge of truly understanding what these models can do.
Moving beyond coarse metrics with UniGenBench.
Which provides that essential fine-grained lens. It helps us pinpoint where models excel, like style and world knowledge.
And where they still consistently struggle, like complex logical reasoning, pronoun resolution, and grammatical consistency.
It really feels like these two innovations work hand in hand. Better training methods informed by more nuanced evaluation.
They definitely complement each other. One helps build better models, the other helps us understand them more deeply.
So maybe a final thought for our listeners. Think about how these shifts from optimizing raw scores to and from broad evaluations to these really specific fine-grained tests, how they change our whole approach.
It's about pushing AI not just to generate pixels that look good, but to actually understand the intricate details, the logic, the relationships we express in language.
This deeper grasp of evaluation isn't just academic. It lets us see precisely where the frontier is, where models are becoming more human-like in their visual reasoning, and where the next big challenges lie.
Mm.
What possibilities open up when AI can handle not just the what, but the how and why in our visual requests?
That's the exciting direction this work points towards.